So now we'll discuss about low power mode 0. In low power mode 0, we have the SMCLK and ACLK operating, which means we can have the peripheral devices operating, but your CPU will be switched off because the MCLK is disabled. Now, how do we disable the MCLK? By making CPU off as 1. So, SCG0, SCG1 and OSC off will remain zeros and CPU off will become 1. And what is the power consumption? We will have a look at that. We'll look at the current ratings. So, LPM0, CPU and MCLK are disabled. SMCLK, that is your subsystem master clock, and ACLK, that's your auxiliary clock, remain active, and your current is approximately 800 microampere. So earlier in your active mode, it was 300 microampere. Now it has reduced to 85 microampere, which is much lesser. This is used when the CPU is not required, but some modules require a fast clock from SMCLK and DCO. Let us suppose you require your timer A to be operating. Okay, so and we have seen the program that we are using the SMCLK. We can use the ACLK as well, but if you want to use the SMCLK, in that case we will use LPM0. Okay. So the next one is LPM3. We are not talking about LPM1 and 2 because it's rarely used. We will talk about LPM3. So now in LPM3, we have ACLK that is active. So now which are the ones that are disabled? MCLK was already disabled in LPM0 itself. We have the SMCLK also disabled. So the DCO is disabled and the DC generator is disabled. Now why we are especially talking about DC generator in specific is LPM2, though we are not discussing it here. LPM2 has the DCO disabled but DC generator enabled. It might not make sense. If the DCO is disabled, why do you require the DC generator there? See, the thing is that if the DC generator is enabled, the coming back to active mode will be faster. Okay, you only have to enable the DCO. So that is the case in LPM2. Okay, but in LPM3, all the SMCLK, MCLK is disabled. So DCO is disabled and DC generator is also disabled. Let us look at the current rating. So it is approximately 1 microampere. So from first we started at 300 microampere, reduced to 85 microampere. We have reached 1 microampere. Okay. This is the standard low power mode when the device must wake itself up at regular intervals. See, waking at regular intervals, suppose you want a real-time clock to be active. Okay. So in that case, we have to have some clock that is running. A low frequency clock will do, and for that case only the ACLK is required. So it is also required if the MSP430 must retain a real-time clock. The current can be reduced to further by 0.5 microampere. It's not 0.5 ampere, it is 0.5 microampere by using the VLO instead of the external crystal. Okay. Now, when do we use the external crystal? We use the external crystal when we require an exact clock. That is when we require an accurate clock. Okay. If that is not required, then we can switch over to the VLO. So now let's just look at the bits also here. So here in the LPM3, we can see that OSC off is 0. All the others, that is the SCG0, SCG1 and CPU off is 1. So LPM0 had only CPU of 1. When we came to LPM3, the CPU off is 1 and the system clock generator bits, that is SCG0 and SCG1 are also 1. Okay, the only bit that is 0 is OSC off. And that also becomes a 1 when you go into LPM4. That is the least power consumed in that mode. So LPM4, all clocks are disabled. Okay. So it is called the RAM retention mode. So the only difference between switching off the device and here is that whatever is there in the RAM will be retained. If you switch off the device, RAM we know is volatile. It will take off whatever data was there in the RAM. Here, whatever is there in the RAM is retained. We know about the dynamic RAM. It has one transistor and one capacitor. So the capacitor should be that recharging should go on so that it retains the data there. Only that happens in LPM4. No clock is there. So MCLK, ACLK as well as SMCLK are disabled, and I, that is the current, is approximately equal to 0.1 microampere. So in active mode it was 300 microampere, and in LPM4 it is now reduced to 0.1 microampere. So if you look at the bits, all the bits related to the low power modes become 1. That is OSC off is 1, CPU off is 1, SCG 0 is 1, and SCG 1 is also